Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Mojazer Senda, BSc 3. In this video, I will discuss to you the topic assigned to me in construction materials and testing, which is the aggregates. So let's get started. So these are the contents that I am going to discuss to you. Number 1, introduction or introduce the materials assigned. Number 2, origin of materials, where it came from, who discovered or invented. Number 3, types of designed materials or categories or subcategories. Number 4, availability, function, processes involved in the materials. Number 5, test and quality assurance for the said materials. Number 6, principles, formulas, equation used for the said materials. Example, manufacturing or fabrications, tests, etc. Number 7, sample calculation for number 6. Number 8, end product, the uses and sample of the said application. So the introduction. Aggregate is an aggregation of non-metallic minerals obtained in particulate form, can be proceed and used for civil and highway engineering construction. Aggregates are mainly classified into two categories. 1, fine aggregates and coarse aggregates. Construction aggregates or simple aggregates is on broad category of coarse to medium grained particulate material used in construction, including sand, gravel, crushed stone, slag, recycled concrete, geosynthetic aggregates. Aggregates are also used as base material under foundations, road, and railroads. Origin of the aggregates. Aggregates have been used as building materials since ancient times. The aggregate industry began to boom with the introduction of the automobile in the early 1990s, as the need of roads paved with asphalt and concrete grew. Ground aggregates are even used in household items like toothpaste, cleansers, cosmetic, and more. The word aggregates refers to the minerals based on materials. Examples of aggregates are typical things you would find in landscape centers such as sand, rocks, boulders, gravel, etc. These materials bind together with other ingredients to create asphalt and concrete, which are also considered aggregates. Aggregates that are derived from natural sources typically come from three different rock types: igneous, sedimentary, and metamorphic. The mineral properties of the aggregates determine the appearance of the rock and also help determine its capabilities, including if and how it can be used. For important, if the aggregate is being used as a paving material. Aggregates contain different chemical properties that helps determine what each specific aggregates will be used for. Aggregates are typically produced by rock quarrying blasting. Rocks are then filtered using screens and crushes and sometimes washed. Slag, topsoil, ballast, type 1 MOT, and geosynthetic aggregates. Synthetic product commonly used in civil engineering project used to stabilize terrain. So these are the types of aggregates. Number 1 is crushed concrete, sand, gravel, type 1 MOT, topsoil, ballast. So crushed concrete, mostly recycled materials. This is produced by recycling waste material from construction and demolition projects. It's perfect for trench fills, backfills, oversight fills, and as granule sub-base for deeper areas over 150 mm. How it is made? It is either gathered from demolished sites or exists from construction projects. Different types of crushed concrete. Number 1 is type 1 crushed concrete, 50 mm down to dust. Best used as a sub-base for roads, underneath blocks, as well as layering in between concrete or tarmac, and as hardcore for projects such as car parks. 6F2, Type 3 crushed concrete, 0 to 63 mm, reduced fine, oversized clean concrete, crushed concrete, 75 mm to 100 mm, no fines. Tarmac plains, screened and unscreened types. Gabion Fail Granite, 75 mm to 200 mm. Demolition and construction site can create large masses of waste building materials. This gives homeowners the perfect material for a sub-base among many other uses. This concrete paving, stones, and broken pieces can be used to build walkways and new paths around the garden. If you want to create, they can also be used to raise garden beds. Number 2, sand. Sand is composed of silicon dioxide in a form of quartz. The planet naturally make it. Sand is a natural-made granular material consisting of finely divided materials and rock particles. Sand composition can be varied depending on their local sources, environment condition. Types of sand. Sharp sand, 0 to 4 meters mm. Used mainly for blocks paving and slab laying. Building sand, laying bricks and block work, and paving slab. Was recycled sharp sand, used for block paving, slab laying, and like. 0 to 0 to 4 mm reject sand for pipe blending. Concrete sand, a key ingredient in cement, but can also be used as pipe sand, a base layer, and a leveling medium. 50-mile radius of the area it surrounds. Number 4, Type 1 MOT. It is approved gradually sub-base materials. How it made? Maybe the sum of rocks such as granite and gritstone as well as other inert materials. Different types of Type 1 MOT. Limestone, 30 mm down to dust. Type 1 crushed concrete, hardcore, 30 mm down to dust. Type 3 granite, 0 to 63 mm reduced fines, permeable. Type of granite, 0 to 2 mm granite dust, 0 to 5 mm granite dust, 2 to 6 mm granite dust, 4 to 10 mm granite dust, 4 to 20 mm granite dust. 10 to 20 mm granite, 6 to 14 mm granite, 20 to 32 granite, 10 to 63 mm granite, 0 to 4 mm limestone, grit sand. Type 1 granite, 0 to 40 mm, reduced fine sprayable. Gavon film granite, 75 to 200 mm. So, MOT stands for Ministry of Transport. Type 1 MOT is a stone that meets the standards of the MOT in terms of its strength, size, and composition for use as a compact sub-base. Number 5, topsoil. Topsoil is a rich soil which has been screened to remove contaminants. Topsoil is a good rich soil which has been screened to remove contaminants. It has many uses such as improving soil quality, grass seeding, and flower bed. How it made? By nature's incredibly slow nature process that can make the country. Different types of topsoil. 10 mm tuffing soil made up of 70 over 30 mixture of sharp soil and sand. This combination is the best for tuff laying as well as sowing grass seed. Horticulture grit, 0 to 4 mm. Best used for planting, potting, and plants drainage. Enriched topsoil. A half and half mixture of 15 mm screen soil and 10 mm compost. This type of soil is best used for borders, rice beds, basket, pots, allotment, etc. 30 mm mulch, compost, and 10 mm compost pit free. A substitute for peat and also act of a soil conditioner. Topsoil is the answer for people wanting their plants to grow in the best possible way. It offers so many nutrients, and there is arguably nothing more suitable. Topsoil benefits the garden because it is assists improving the nutrient cycle. Works. How it made? Typically made of crushed stone, although ballast has often consisted of less suitable materials such as burnt clay. So different types of ballast. 0 to 10 millimeter ballast and 0 to 20 ballast. Concreting foundation and a sub-base. 20 screen ballast and recycled 20 screen ballast. Driveways, footpaths, oversight fields, and sub-bases. As rice ballast, blending hardcore backfill and driveways. Overland infrastructures, the ballast is also used as a stability aid for vehicles such as boats, submarines, ships, even race cars. So the availability, function, processes involved in the aggregates. The aggregate gives volume stability, resistance to wear or erosion, and other desired physical properties of the finished product. During the processing, aggregates are distilled down to a level of their most common use. Some aggregates may be crushed to a powder, while others may be screened to various diameter chunks. The proper processing of aggregate is most important in maintaining their desirable qualities. For instance, between 60 to 70% of concrete consists of both coarse and fine aggregates. If the aggregates are not properly sized as well as clean and free from other matter, the concrete could fail to meet its desired strength and cause structural failure. Likewise, it is essential that felt parts and laminate aggregates are proceed to their purest form for effective medical and chemical use. Types and quality for the aggregates. Number 1, surface moisture content and absorption test. The surface moisture in the aggregates influence the water-cement ratio, strength, and durability of the mix. To determine the surface moisture of moist or wet aggregates, method is as follows. Frying pan method. The following apparatus are required: a frying pan or metal tray, gas stove or an electric hair dryer, a metal or glass stirring rod, and scale to measure. The following procedure is followed during the test. Number 1, the coarse aggregates 2 kg sample is adequate, and for fine aggregates 0.5 kg sample is adequate. All over W sub SD times 100%. Overheating must be avoided as it will not give you the correct surface moisture. If heating is continued either the fry pan or in the oven till the aggregate is bone dry, aggregate weight is in the noted after continuous heating. The absorption is calculated as follows. Absorption is equals to W sub SD minus W sub BD all over W sub BD times 100%. Similarly, if the dry aggregates is received on site and absorption capacity to the determined, then the aggregates are first soaked in water and then the above methods are deployed to determine the absorption capacity of aggregates. Number 2, silt content test for sand. The permissible silt content in sand must not exceed the value as specific in standards. However, this method can be only used for natural sand. It should not be used for crushed rock sand. The apparatus required for this test is only 250 mg glass measuring cylinder. The silt content determination by volume is done in the following manner. The glass cylinder is filled with salt water solution up to 50 ml mark. Number 2, add sand until the level of the sand is up to 100 ml mark. Add further sand water solution till 150 mark is reached. Place the pan on the mouth of the glass cylinder and shake it vigorously. Place the cylinder hard, level surface and tap it all around so that the sand is leveled. Wait for 3 hours for the silt to settle on top of the sand. Measure the thickness of the silt layer and the weight of the sand. The silt content can be calculated as follow. Silt, percent yan ha, volume by volume is equal to thickness of the silt layer all over weight of the sand plus silt times 100. If silt content by weight exceed 3%, then washing of the sand is necessary. After conducting few tests, a correlation can be developed for the silt thickness and various interval of time. The silt content of the 10 minutes can be fixed as inspection criteria. Bulking sand. When the sand is damp and the water coating in the surface of the each particles causes separation particles from one another due to surface tension. This causes sand to bulk. Bulk sand occupies more volume and hence if volumetric measuring is done when proportioning, bulking correction is necessary. The bulking test is done as follows. The sand is filled in loose condition in a box of measuring height. The box is then flooded with water or brooding is done to make the sand settle and consolidated. Care should be taken that sand does not overflow during the flooding and compaction. The sand is then leveled in the box and the drop height is measured. Bulking is calculated as bulking percent is equal to H over H times 100%. Dry sand occupies the same volume as fully saturated sand. The bulking will vary from load to load and day to day depending on the finish of the sand and its surface moisture content. It is therefore very essential to make a bulking correction by checking the actual bulking of the sand proposed to be used by volumetric batching for mortar and concrete. Example of the fabrications. Number 7. So these are the manufacturing or fabrication, tests, etc. Aggregates crushes is used for primary, secondary, fine crush of stones such as granite, gravel, quartz, basalt, limestone, boulders, feldspars, dolomite, and other stones and rocks. The crushed stones with different particle size, usually 0.40 mm, can be used as aggregates in construction, building, roads, highways, and other industries. Quarrying. So these are the fabrications, no? Quarrying, hauling, crushing, screening, washing, delivery, and so on. So the end products. Aggregates are used in construction to provide drainage, fill voids, project pipes, and provide hard surface. They are also used in water filtration and sewage treatment processes. This natural process can be replicated in treatment works to remove suspended solid from surface and stored water before disinfection. So use of aggregates. Aggregates is essential ingredients of concrete. The use of aggregates is essential in the uses of aggregates in concrete is increases the volume of concrete, thus reduce the cost. Aggregates account for 60 to 75% of the volume of concrete and 79 to 85% weight of PCC. To provide a rigid structure to reduce the shrinkage and cracking, concrete aggregates is used in many structures and substructures. Example, different elements of buildings, bridges, and foundations. The smaller the aggregate size is, the greater its surface area and the more binding materials will be required, resulting in higher cost. The greater the aggregate size, the larger will be the voids, resulting in wastage of binding materials. Hence, I make sure of coarse and fine aggregates is used in concrete to avoid both these problems. So that's all for this video. I hope may natutunan kayo kahit papaano, no? Isasend ko din tong PowerPoint ko sa GC. So, once again, I'm Mojazer A. Senda, your reporter number 4 in Aggregates. Thank you so much and goodbye.